Solve the system of equations by the substitution method. In this problem, since each of these equations is solved for y, all we have to do is set them equal to each other. X squared minus 6x plus 7 equals x squared minus 11. Notice that the term x squared is identical on both sides, so when you go to subtract that from both sides, it's going to be eliminated. So we end up with a linear equation, negative 6x plus 7 equals negative 11. That exponent of 1 there means there's only going to be one answer. Subtract the 7 from both sides. Negative 6x equals negative 18. Divide by negative 6. X equals 3. Now, when you're solving a system that involves an x and a y, you have to remember that this is just part of the solution, that we're looking for the points where these two curves intersect. So we'll need to substitute this 3 into either one, and it doesn't matter which one because you'll get the same result. And since this second equation is a little bit shorter, I'll say y is equal to 3 squared minus 11. That's 9 minus 11, which is negative 2. So the solution set for this one is the ordered pair 3, negative 2. So these two curves only intersect at that one point where x is 3 and y is negative 2. Now let's look at another one. This one also says, solve the system by the substitution method. So if you're going to use substitution, one of these two equations needs to be solved for either x or for y. And which one you choose to solve is up to you. If you do the first one, x, y equals 40, you could divide both sides by x to get y is equal to 40 over x. And then you can substitute that into the other equation. Or I could solve this one for y and say 2x plus 2 equals y. By adding 2, it'll be a plus 2 on this side, and by adding y, so this is the other option, and I can put that into the first equation. Your method does not matter. Now, some people would be afraid of this fraction, so we'll do it the second way. So if x times y is 40, and y is equal to 2x plus 2, that's going to be 2x squared plus 2x minus 40 equals 0. I'm going to factor out a 2. X squared plus x minus 20 equals 0. And this 2 is irrelevant since it's never equal to 0. So we're just going to factor this trinomial, x plus 5 and x minus 4. So here are two possible values for x. X plus 5 equals 0 if x is negative 5, and x minus 4 is 0 if x is 4. Now we must go back to either original and find the y's that go with these x's. So this first one is easiest for that. If x times y is equal to 40 and x is negative 5, negative 5 times y is equal to 40, so y is negative 8. So the first one is negative 5, negative 8. The second one, x times y is 40. When x is 4, 4 times y is 40. Divide by 4. y is 10. So if x is 4, y is 10. So this time our solution set involves two ordered pairs, -5, -8, and 4, 10. Last example. This time we're going to solve the system by the addition method. Now the addition method works well when neither of these equations is easily solved for x or y. And it's not easy to solve for x or y if you have x squared or y squared, because that would involve taking the positive and negative square root. And you definitely don't want to get into that. So what I notice is that if this is a -2y squared, if this was just a positive 2y squared, I could add these together and I could eliminate the y squares. So I'm going to leave equation 1 just like it is, x squared minus 2y squared equals -14. I'm going to multiply this equation by 2, and that's going to give me 8x squared plus 2y squared equals 50. Now by combining or adding these equations, the y squares are eliminated, and I get 9x squared equals 36. Now you can subtract that and factor it. Remember, there are going to be two answers. Divide by 9. X squared equals 4. There are two answers because it's positive and -2. The square root property says if x squared is a number, then x is the positive and negative square root of that number. So x is plus and -2. Now we have to go back and put +2 and -2 in either of these equations. I'll just do the second one because it's got a plus. Seems to be a little easier. So I've got 4x squared plus y squared equals 25. I'm going to go x is 2, and then I'm going to do x is -2. If I put a 2 here, that's 4 times 2 squared plus y squared equals 25. That's 16 plus y squared is 25. That gives me y squared equals 9 if I subtract 16 from both sides. So y is plus and -3. So that means when x is 2, y is 3, and when x is 2, y is also -3. So those are my first two answers. Now I have to put -2 in here, and what you'll notice, if I put a negative right here, that's still going to be 4 times 4, or 16. So when I put in -2, I'll get a 3, and -2 will give me a -3, because this is going to work out exactly the same as it did before. When I put in a 2, it's going to be the same when I put in a -2. So in this case, there are 4 points where these two curves intersect. So 2, 3, 2, -3, -2, 3, that is our solution set for this example.